Sixth grade lesson 7.4 is identifying parts of expressions. And really, this is just allowing your brain to get a chance to understand what are the parts, what are the pieces. It's helping it get deeper, your brain get deeper into how to solve them. If you understand the parts, that helps you with translation from word problem into an expression. It helps you with the solving of it. So it's just giving your brain some time to understand all the parts of it, breaking it down for us, giving us the foundational pieces. So let's go ahead and what you'll notice is that I went ahead and put this translation piece from the last lesson back on there in case you need that available to you as we go through these parts. Let's go ahead and take this word problem. They broke it down to the expression for us, but let's see how they went from here, word problem, to expression. And then let's identify the different parts of the expression, just so your brain can understand all of the pieces that are into place, so that you, when you do have to convert it from English to Mathese on yourself later, it's a little bit easier because you're understanding things a little more. Start by reading. At a garden store, seed packets cost $2 each. Martin bought 6 packets of lettuce seeds and 7 packets of pea seeds. The expression 2 times 6 plus 7 represents the cost in dollars of Martin's seeds. Identify the parts of the expression and then write a word expression. So this is the math expression, Mathese. They want us to write the English version of this as the final product here, what they want us to do. So that's what they want us to do. Let me not cross that out. Let me underline. What do I know? I know that each seed packet is $2 each. And I know that he bought 6 packets of lettuce seeds and 7 packets of pea seeds. Over here they said, explain how you can find the cost of each type of seed. Well, we don't know the cost of each type of seed, but I could say he did $2 for each lettuce seed. And he did 6 of those. And $2 for 7 pea seeds. So I could do that way. They did this as I have 6 lettuce seeds, 7 pea seeds. Add those together to find out how many bags of seeds that I have. And then multiply by 2 because each packet of seeds is $2. So that's how they translated the expression into Mathese, a numerical expression. What will I be doing? Identify the operations in the expression. I'm going to multiply and I'm going to add. So I'm doing a multiplication and addition, I should say, to keep it English, use my English skills. The part in the parentheses shows the addition, we should put add there, of 6 and 7. The sum represents the sum of those two numbers, the 6 and 7. Remember, sum is the answer to an addition problem. That is referring to the packets of seeds. Oh, they want it broken down to the packets of lettuce seeds plus the number of packets of pea seeds. One of the factors is 2, right? Because it's the 2, the dollars, $2. The other factor is that combination, the addition of the sum of 6 and 7 put together. So I'm multiplying 2 times that sum together. The product, remember, product is the answer to a multiplication problem, represents the $2 per packet times the number of packets Martin bought. 2 times the number of packets. So the way I could write this in English, so here it is again in Mathese, is the product, because we have that multiplication going on, of 2 and, so product of 2 combined with the sum of 6 and 7. So the product being multiplication of 2 and the sum of 6 and 7. I'm multiplying 2 times whatever 6 and 7 added together is what we're saying there. Okay, and so let's talk about a few vocabulary pieces too that are going to come into play as we go through this. One piece of vocabulary is the word term. And a term is the parts of a numerical expression or an algebraic expression that are separated by an add or subtract. So if I have 4k divided plus 5, 4k plus 5, right? Then I have a term of 4k, remember that's 4 multiplied by k, and I have a term of 5 being put together. Those are both terms. What if I have 2x plus 8? That's a term, and that's a term. What if I have 3a minus 4b? That's a term, and that's a term. Another vocabulary word they throw at us in this section is called a coefficient. And a coefficient is a number that is multiplied by a variable, usually a number sitting right in front of its variable. Remember earlier we talked about that can be written as 4 times k, but we get used to seeing it as 4k, 4 times k, 4k. The coefficient is the number, oops, I don't want yellow. I meant for that to be a highlighter. The coefficient in that term is 4 because it is the number that's multiplied by the variable k. The coefficient in this term is 2 because that is the number being multiplied by the variable. There isn't a coefficient in this one because it's not being multiplied by a variable. No coefficient in this one. This has a coefficient. What's the coefficient in this term? Yes, you're right. 3 is the coefficient. It's 3 that's being multiplied by the variable. This term also has a coefficient. What is it? Yes, 4. So that verbiage is the coefficient. You will hear me use that over the next couple of years when we're in 7th grade math and 8th grade math. We use the vocabulary term and coefficient much more frequently. So it's good to get your brains used to that right now. Okay, so in this example, they want us to identify the parts of the expression and then write a word expression for this algebraic expression 2x plus 8. Well, the expression is the sum. Remember, I'm adding two terms together, the sum of two terms. Oh, I want a better color than that. My two terms, this one and this one, right? The terms are, they already put 8, so the one we're missing is 2x. I'm adding 2x and 8 together. The first term is the product. Remember, that's 2 times x, product, right? The first term is the product of the coefficient 2 and the variable x. The second term, this guy, is the number 8. So now that we've broken it down, a word expression for 2x plus 8 is 8 more than, because it's plus 8, so 8 more than the product, because we still have to multiply 2 times x when we know what 2 times x is going to be. So the product of 2 and x. So that's how the translation can happen from the expression into this. You could also say the 2 times x added to 8. There's another way to put it. I mean, there's several ways, right? The product of 2 and x added to 8. Or the product of 2 and x plus 8. Or 8 added to the multiplication of 2 and x. So several ways to put it. There's not one right or wrong way. We have another set of terms here. 3a is a term, and subtracted from it is 4b. I can say that as my translation. 3 multiplied by a, the difference between 3a and 4b. I could say that. I could say 4b, the multiplication of product of 4b subtracted from the product of 3a. There's a lot of ways to put it, but let's break it down the way they have it. We're going to identify the terms in the expression. The expression is the difference. It's subtract, right? So subtract is my difference. It's in here somewhere. Difference isn't on there? Okay, guys, everybody write difference on there. By now, you guys know that's the difference up. The subtraction, the difference. Okay, the expression is a difference of two terms. The terms are 3a, and 4b. I'm taking 4b away from 3a, right? The first term, 3a, is the product, because it's 3 multiplied by a, is the product, multiplication, of 3 and the variable a. And the second term is the product of the coefficient. Oh, that's what they wanted here. Whoopsie. Is they already used product. They want the coefficient of 3 and the variable a. And the second term is the product of the coefficient 4 and the variable b. So a word expression that we could use is the difference of 3 times a, they have the multiply there, 3 times a, and 4 times b. The difference meaning the subtraction there, the term 3a and the term 4b. Several ways to write it, but if you break it down, that's one way you can write it out. You can use these tools to help guide you how to verbalize it in English. Let's do one more practice one together. And again, there are several possible answers for how I verbalize this in English. So I just need to break down what's happening. First thing that I see happening is that overall my two terms are 5m and 2n, and they are being added together. So I'm going to find the addition solution of sum. So I'm going to use the sum of. Okay, so that took care of this part, the sum of. Well, the sum of what? What am I adding together? I'm adding together this 5m term, which we know is 5 times m. Let's go to product for that. The sum of the product of 5 and m with, now let's look at this one. This term is 2 times n. So we'll use again the product. So we have currently the sum of, that took care of that, the product of 5 and m with the product of 2 and n. Now I've identified my terms. So I'm adding together two terms, adding together the sum of. One term is the product of 5 and m, that, with, that's why I'm adding them together. So I'm adding this one with the product of 2 and n. So that's one way you could do it. There's several other ways that you can use these words to translate that into explaining it in an English format. So but that's just how you break it down. Just break it down what calculations are happening. Use this to help you. So that's what this lesson is about. Again, just giving your brain time to recognize all these pieces before they start adding into it. Okay, now we're going to start giving you how you can evaluate them if we tell you what they are. But this just lets your brain kind of see, okay, what calculations are going on. Also giving your brain a chance to get used to that being a multiplication problem, 5 times m, 2 times n, recognizing terms. So that's what this lesson was about. Let yourself go through the practice of these. Will you make some errors in it? Maybe. Will your answers be wrong if it's not exactly like the teacher's edition answer? Not necessarily, because look at how many possibilities there are vocabulary-wise for each of these operations. So just because your answer doesn't match the teacher's edition answer doesn't necessarily mean it's wrong. So I want to make sure that you understand that too. So just as long as you can see what calculations are happening with what. So I would always start with what's being put together, what terms are being put together, and then identify the terms, product of 5 and m, product of 2 and n, if there's a product going on. So if your answers aren't exactly the same as the teacher's edition, that doesn't necessarily mean they're wrong. Have somebody work through with you if those make sense for what you're seeing algebraically. Okay, good luck.